Alright class, this is another day on identities. I'm going to skip this review section though and go down to a couple tips that we didn't talk about yesterday and then do the 3 identities on the back. So let's go do that. So the thing is, again, you're going to try to match denominators or numerators on each side of the fraction. So if you want to pause the screen and write that down, you can. The other thing you need to remember is look for either factoring abilities. So look for GCFs that you can pull out. Look for difference of squares. Remember the trig identities, the Pythagorean identities lead to, I'll write that down, usually lead to conjugates or difference of squares. Well, I guess that difference of squares factoring gives you conjugates, so alright. Anyway, let's see what we can do with this, because really all you can do with identities is look at them and try them. So the first one is I have 1 minus sine theta over cosine equals cosine over 1 plus sine. So I look at this and I see that I need a cosine on the top. I'm trying to get the left side to look like the right side. So I know that the right side has a cosine on the top, so I'm going to try to match that by multiplying the top by cosine theta. And you have to multiply the bottom by cosine theta as well. So then I get cosine of theta times 1 minus sine of theta over cosine squared of theta. Okay, so I know I want that. Well, I don't want this thing in here anymore. It's going to have to cancel with something on the bottom. Well, I do have cosine squared on the bottom now, which is it's my identity. I can change that into 1 minus sine squared theta. If you remember from yesterday's video, that's one of our identities. Now this is what I was talking about in the tips. When you do a trig identity like that, and you have 1 minus sine squared, think of difference of squares. You can take the square root of that and there's a difference, so you could write them as conjugates. So I'm going to write this as 1 minus sine theta and 1 plus sine theta. So we can use difference of squares, diff squares, to get to this. Alright, and then you should see that these cancel and we are left with what we want. Cosine of theta on top and a 1 plus sine theta on bottom. That was what we had at the beginning. Okay. So again, I saw I needed a cosine on top. I did that first. That gave me cosine squared on the bottom, which I can transform into 1 minus sine squared. I can factor it and then cancel. So that's the type of stuff you're supposed to look for. Okay, I don't know why this keeps cutting things off. Now this one can take you very long or very quickly. If you look at this, the only thing, they both look very similar, so you can work the left or the right. There's nothing squared, so we can't do any identities like that first. We could rewrite cosine as 1 over secant or secant as 1 over cosine, and that'll make it a little messier. But here's what you have to recognize. I want a 1 here, and I want a secant here. Actually, you know what? Let's work this side. We never work the right side. So if I'm working this side, I look at the left side, I want a cosine theta in this spot. So the best way to do that would be to multiply this whole thing by cosine theta. And if you do that, you have to multiply by cosine theta on the bottom. So look what happens when I do that. I multiply the 1 by cosine theta, and I get cosine theta. Plus, I multiply secant by cosine. Now hopefully you guys remember that those are reciprocals of each other, which means they give you a 1. The bottom you multiply cosine times 1, you get cosine theta. Minus, again, secant and cosine is a 1. And sure enough, that's what I wanted. So if you can recognize that the things on either side are kind of reciprocals of each other, there might only be a step that's necessary to get you to the final answer. There are other ways to do it. In fact, one of my classes knows that because we did the long way in class. But overall, that would be the fastest way. Okay. Oh, what do we do here? What do we do here? Well, I think what I would do first, now you cannot just cancel these out and cancel those out. That doesn't work because of the minus sign. So if you're thinking that, that is not correct. A couple things you can think of. You can work the top and the bottom separately. Make them into a fraction over a fraction. Let's do that. So I have sine squared theta minus sine theta over cosine theta. That's just on top. That's just this. I'll change colors so you guys can see what I'm doing. So the bottom becomes cosine squared theta minus cosine of theta over sine of theta. All I did was change tangent and cotangent. The next step is you want a common denominator. Whenever I have mini fractions like this, I want to get them together. Okay? So then I get, and over here I can do the same thing, but I want a sine. Okay? So then this becomes cosine theta sine squared theta minus sine of theta over cosine over the bottom is again sine theta cosine squared theta minus cosine theta all over sine theta. Okay. Oh, I pretty much ran out of room, so I'm going to go to the right over here. So now, when you have a fraction over a fraction, there's two things we can do here. We can either simplify this or do the fraction over a fraction and make it multiplication. We have to take this one and flip it up and multiply it to the other one. So I'm going to take this whole thing over here. I have cosine of theta sine squared theta minus sine of theta over cosine theta times sine of theta over all of this. Alright, so remember, with multiplying you really want to cancel things. Well, I can't cancel anything yet, but I have to look for, in order to cancel you need to factor. So I'm going to look for GCF opportunities. So in this piece right here, I have a sign in this big chunk in the front and a sign in the back. So I could take a sign out of this, and then I'm left with cosine theta cosine theta times another sine theta minus 1 over cosine theta times, this is still a sine theta, and on here I can take out a cosine theta. So I'm left with sine theta cosine theta minus 1. Now that I've factored, I look for anything that can cancel, and sure enough, I have a sine cosine minus 1, sine cosine minus 1. These go away. I'm left with a sine and a sine, so I'm left with sine squared theta. And on the bottom, I'm left with cosine and cosine, cosine squared theta, which is tangent squared theta, which is what I wanted. So sometimes it's a lot messier than it looks. So you just have to check and keep working at it and see that you get there. Okay? Alright, well that is it for identities. Keep looking at these, keep practicing them.